Students, we are given this question. A circle of radius 3 units touches both the axes. Find the equation of all possible circles. So let us try to visualize this question. So we got the x-axis here and y-axis, and we are expected to draw a circle of radius 3 units. Now the circle has to touch both the axes. So that means if I were to draw a circle which touches x and y, then it has to be drawn so that its radius from this point to the center is 3 units, and similarly the radius from the axis to the center should also be 3 units. Okay, so if I were to complete this circle, then the circle would be something like this. Okay, now we are expected to draw circles like this for all the other quadrants, because the question wants us to give the equation of all possible circles. So in this case, my x value will be 3 and my y value will be 3. But if I were to draw the same circle on the left side, that is on the second quadrant, then my x value will be negative 3 and my y value will be positive 3. So if I were to do the same thing to the third quadrant, my x value will be negative 3 and my y value will be negative 3. For the fourth quadrant, my x value will be positive 3, but my y value will be negative 3. So what you are expected to do is you have to obtain the equation of the circle for each of these quadrants. So quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Why are we doing it? Because the circle is stated to be touching the axis, both the axes, the x and y. So in that case, you will also have a circle here, circle here, circle here. So I'm going to show you how to obtain the equation of this first circle. So let me name this C1. So the equation, let me start by using the term therefore. Therefore, the equation of C1, I'm using the equation of circle in standard form. That's going to be x. The center is given to be as 3, 3. So I'm substituting the value of h as 3 raised to the power 2, positive y negative of 3 raised to the power 2. The radius is given to be as 3 units, so it's going to be 3 squared. So if you were to expand this, you will get x negative 3 raised to the power 2 squared, followed by y negative 3 raised to the power 2, followed by equal to 9. So that in turn is simplified as x squared negative 6x positive 9 positive y squared negative 6y positive 9 is equal to 9. So rewriting, it's going to be x squared, let me write the y squared term, positive y squared negative 6x negative 6y. Now 9, 9 and a negative 9. If I were to bring this, it is going to be negative 9. So that would mean 9 positive 9 negative 9 is equal to 0. So a negative and a positive 9 gets cancelled, giving me x squared positive y squared negative 6x negative 6y positive 9 is equal to 0. So this is the equation of the circle for the first quadrant, for C1. Now if you were to repeat this process, then you will clearly find that in general the required equation of the circle of all the circles would be x squared positive y squared plus or minus 6x plus or minus 6y positive 9 is equal to 0. You can verify this. Okay, by the technique that I have shown you here, you can verify for each of these quadrants, and that completes the solution for this question.